So you should remind me in the beginning only. If I forget. Okay. So that is the beauty of your partition view. Okay. So now tell me, when should I go for a partition view? So as I said, when it comes to your real-time environment, for example, when it comes to banking application, right? This is your real-time DB. So whatever is happening through UI, each and every transaction will get recorded into your real-time DB. And when it comes to banking, many people will be working inside banking, right? To support all banking operations, right? So every organization will have a lot of employees to support their operations. When it comes to banking, there will be different wings, and you will see different people working for the banking application, right? So in order to support all the operations of banking, the bank will recruit some people. If you grant access directly to this real-time DB, what happens? So if the person is allowed to work directly on this real-time DB, he might make some mistakes. If something goes wrong, you may lose your data. If the data is lost, from where can I roll back it? There is no other source. There is no copy of this. It is very difficult to roll back your data. All right, to me. So that's why when it comes to real-time application, so what they will do, they will never allow any employee to work directly on the real-time DB. Because if the employees of your banking are allowed to work directly on this, they might make some mistakes. And if everyone is allowed to work on the same DB, what happens? The burden will be increased on the system. So that will definitely degrade performance of your application. That's why when it comes to real-time environment, so what they will do, they will create a replica of your real-time DB. Replica 1, replica 2, replica 3. Okay, so they would create the replica of your real-time DB. Okay, replica means whatever is in the real-time DB, they will clone everything as is, except data. The database structure and everything will be cloned into a replica. And every day after business hours. So in the real time, they will create a job or service. That service will take care of pushing this data into your replica. They'll schedule a job that runs at regular interval. Let's say every day after business hours or at 9 p.m., 12 p.m. So they will decide the timings based on their requirement, when it should run. So once the job is started, the service is started, it will take care of pushing your real-time data into replica. So whatever is there in the real-time DB, the same data copy will be there in your replica. Now, when it comes to employees of that organization, we will grant them access to only replica. We will never grant them access to real-time DB. Alright, because whatever is in the real-time DB, we push that same data into replica. Right? So now they can work with replica. If they make any mistake in the replica, no issues. You have your original copy. Right? From this original copy, you can build a number of replicas. If anything goes wrong, you will be on the safer side. Right? That is one scenario. And second scenario, let's say from your real-time DB, we are getting millions of records every day. Every day, it is pushing millions of records. If you keep on pushing millions of records every day, at some point, your table will get overloaded. You will see a lot of records in this table. When you search for a single record, what happens? In order to identify a single record, it has to search all millions of records. If you keep the complete set of data into one table, it will be overloaded. Once it reaches a certain point, your search process will become slow. It will degrade performance of your operations. It will slow down your search process. So that leads to a problem. To avoid this, what has to be done? If any table is overloaded, better get that split into multiple replicas. Multiple replicas. Replica 2, replica 3. Multiple replicas. If this table is having 30 records, get them divided into 3 tables. 10, 10, 10. If it is having 3 million records, get them divided into 3 tables. 1 million, 2 million, 3 million. This will have 1 million, this will have 1 million, this will have. So whatever is coming from your real-time DB, so that has to be split into 3 different tables based on some condition. For example, this is going to push data from 2010 to 2022. Right? Now the data has to be split into 3 tables. How do I decide this? Based on what? So based on year, we can decide. Oh, from 2010 to 2015, that data should go to replica 1. 2015 to 2020 should go to replica 2. 22 and till now should go to replica 3. Right? So we are dividing the table into multiple tables. This concept is called table partitioning. Right? So whenever your table gets overloaded, get that divided into smaller tables and get them connected logically. The process of dividing your table into smaller tables is called table partitioning. Okay. And whenever any new record comes, what has to be done? Now you should decide it should go to which table, where replica 1, replica 2, and replica 2. How do you decide it? So based on that year of that particular record, and the redirection has to be decided, right? So if the year falls between 2010 to 2015, should go to replica 1. If that falls between 15 to 20, should go to replica 2. Otherwise, it should go to replica 3. So you have to prepare a condition based on your requirement. In this case, I wanted to push data based on the year. But according to your requirement, you can choose any field to decide where it should go. Okay. So this is called table partitioning. But who will decide where to go? Whenever any record comes from your real-time DB, there should be someone you should take care of redirecting your record into respective table. Whenever any record comes from your real-time DB, there should be someone you should take care of deciding where to go, to which table the record should go. So that someone is going to be your partition view. That someone is going to be your partition view. That someone is going to be your partition view. So whenever you want to create a partition view, so what has to be done? First, you have to partition your table. First, you should split your table into smaller parts. Okay. So let us assume that we have a table called part. Now I would like to divide that into 3 parts, part 1, part 2, and part 3. That table is going to have 3 columns: product ID, product name, and expiry year. Now I'd like to divide these tables based on the expiry year. If the expiry year falls between 2010 and 2015, it should stay in part 1. If that falls between 2015 and 2022, it should get inserted into part 2. If that is greater than 2022, it should go to part 3. Okay. So whenever you want to divide your table into smaller parts, as I said, you have to decide based on what the data has to be split. In our case, based on expiry year, I'd like to divide my data. Are you with me? So data from 2010 to 2015, I want to keep it in part 1. From 15 to 22, I want to keep it in part 2. So here, our key field is going to be expiry year. Now, based on this, whenever any new record comes for insertion from your real-time DB, so here we have to decide. How do we decide? We have to check its expiry year. If that falls between 2010 and 2015, it should be inserted into part 1. If that falls between 15 and 22, it should be inserted into part 2. Otherwise, it should be inserted into part 3. Okay, so here I'm choosing expiry year, but it differs from requirement to requirement. Based on your requirement, you can choose anything, but choose a key field that will divide your data logically into 3 tables. Okay, in our case, I want to choose expiry year. Okay, so first let's divide your table into 3 tables. How do I divide these? Create table part 1, keep your names, your fields, product ID, product name. Here I'm taking only 3 fields, but when it comes to real-time tables, there can be a number of fields. And expiry year. But as I said, if you want to partition your table, you have to take care of 2 things. First thing, you should tell the system based on what the data has to be routed. So as I said, it has to consider the expiry year. If the expiry year is greater than or equal to 2010 and less than 2015, the data should go to part 1. So here you should define that condition. So that's why we need a check constraint. I'm keeping a check constraint. So you have to keep a check constraint. This check constraint will be used by your view whenever you want to insert a new item into respective table. So whenever any new record comes, it will check the expiry year of that new record. If this condition gets satisfied, it will go to part 1. If this condition gets satisfied, it will go to part 3. So based on expiry year, the record will be inserted into respective table. So that's why a check constraint is mandatory for table partitioning. Okay, so this is my column, expiry year, and I'm going to split my data based on expiry year. That's why it should have a check constraint. Write your condition from where to where. So it should be greater than or equal to 2010 and less than 2015. And second condition, you should create primary key on both a unique column as well as the column that is being used to split your data. On the combination of a unique column and a column which is being used to split your data should have a primary key. These two are mandatory. Whatever the key field is going to be used to split your data should have a check constraint along with the condition, and it should have a primary key. These two conditions are mandatory. And create part 2, PID, PName, expiry year. Year condition is going to be what should go to part 2 between 2015 and 2022. Again, it should have a primary key. Next, part 3, right? Now, who will take care of deciding this? Who will insert the data into respective view? So that is going to be your partition view. That is going to be your partition view. So how do I create it? The creation of partition view is very similar to your ordinary view. Create view name with schema binding. Why do we need with schema binding? So if any table gets deleted, first it will let your view know about it, right? Because it is having dependency over these 3 tables. If I keep with schema binding, if someone try to delete your table, it cannot be deleted. It cannot delete your table. Okay, so that's why you have to keep with schema binding. Now what should I do? This view is going to take care of extracting data from all the 3 tables, part 1, part 2, part 3. It will take care of inserting data, updating data, and extracting data of these 3 tables, right? I should get data from part 1 as well as should get data from part 2, should get data from part 3, combine all the result sets. That's why inside your view, I'm using union all operator because it is going to work on all the 3 tables. Select data from part 1, union all. Select data from part 2, select data from part 3. So what it will do? It will select data from part 1 and combine it with part 2, and part 1 and part 2 combined will be combined with part 3. So basically this operation will take care of combining data from all the 3 parts, part 1, part 2, and part 3. So whenever I say select star from my view, what it will do? It will extract the data of all the 3 parts. And whenever I try to insert a record through this view, now what it will do? Now it should decide that record should be inserted into whether part 1, part 2, or part 3. Read me. So that's why here we have given these conditions. Whenever any new record comes, now our view has to decide where to go, because this is the one which will take care of redirecting that record into respective table. Let's say we are trying to insert a record through your view. For example, something like this: insert into view values 102 DFDF, expiry year is 2023. Now what your view will do? It will check the expiry year. Okay, and first go to part 1. What is the check constraint here? Expiry year should be between 2010 and 2015, but here it is 2023. So this condition is not getting satisfied. Next, it will go to part 2. 2023, here it should be between 2015 and 2000. So this is also not getting satisfied. Now it will go to part 3. Yes, this is getting satisfied. Now this record will be inserted into part 3. Are you getting me? Now this record will be inserted into part 3. Select star from see. Select start from part 1, part 2, part 3. Part 1 is having 1 record, part 2 is having a record, part 3 is having 2 records. This is what we have inserted recently. Let's insert one more record, 104. Some FFFF. Year is 2011. 2011. Now, where it should be inserted? First, when you try to insert any new record through your view, what it will do? First, it will go to first table, part 1. It will check where this expiry year falls between 2010 and 2015. Yes, 2011 falls between 2010 and 2015. So this will be executed. It means this record will get inserted into part 1. Let's see. Record got inserted. Now it got inserted into part 1. Right? So we are able to insert records into all the 3 tables through this view. This is taking care of inserting data into respective partition table. That's why we call it as partition view. You don't have to go to every table and divide them manually, right? If you use partition view, it will take care of redirecting the record to respective table based on set of conditions. Here, in our case, that condition is going to be expiry year. Whenever any record is inserted to your view, so first it will check that respective condition. If that gets satisfied, it will be inserted into respective table. That is the use of partition view. Any questions, guys?
No, sir.
Okay. So this is something about your views. Next, these are the main advantages of view. What are the advantages of view? The first thing is it is a pre-compiled code. It will be executed directly without any compilation. So it will speed up your process. Your compilation plan, execution plan will be reused every time. Second thing, your query will be saved physically in the database. Whenever you want to insert something, update something, extract something, you just need to call your view. You don't have to pass a direct SQL query. So we can reduce the risk of, we can minimize the risk of SQL injection. It is very difficult to hack your SQL. It is very difficult to inject malicious data. And coming to this partitioning of your tables can be easily managed through your partition view. And when you talk about a view is a virtual table. Okay, so it doesn't contain any data physically. It is also kind of a database object, but it will be stored on your table, and whatever the changes made to your table will be reflected directly into your view. If any static gets updated, or if any indexes are created, so that changes will be reflected automatically into your view. That's why view will be working very faster compared to your direct SQL query. These are the advantages of view, but at the same time, there is a disadvantage. What is the disadvantage? View doesn't take any parameters. View doesn't take any parameters. If I want to supply anything from outside, I cannot do that. Like your subprogram, it cannot work like a subprogram. What is a subprogram? A subprogram accepts parameters. If whoever is calling your object, your subprogram, if they want to supply some values from the calling environment, then your corresponding subprogram should have those many parameters, right? If I want to supply something into your view, I cannot do that. Right? Because view doesn't accept any parameters. So that is one of the biggest disadvantage identified with your view. Okay. So if you want to write it like a subprogram, if you want to accept parameters from outside, from calling environment, and if you want to write some advanced level query programs, then your approach should be towards another concept that is called stored procedures. Stored procedures. Stored procedure. What is the difference between a view and stored procedure? Simple. A view doesn't contain parameters. Everything is similar. View is a pre-compiled code. which will be executed directly without any compilation. And stored procedure also is very similar to view. This is also one of the pre-compiled code. You can keep any SQL programming inside your stored procedure. But the difference is your view doesn't work like a subprogram. It doesn't accept any parameters, but your stored procedure accepts parameters. And inside view, the SQL programming is limited. You cannot use all SQL options. But inside stored procedure, nothing is limited. You can write any advanced SQL option. You can write any advanced SQL programming inside stored procedure. Everything is allowed inside stored procedure. And it will be very similar to your subprogram, your C# subprogram, which accepts different types of parameters, input parameters as well as output parameters. You're aware of output parameters, right? In C#. Input parameter expects something to be supplied from the calling environment. Output parameter would return something back to the calling environment. Okay, so if you want to overcome the drawbacks of your view, your approach should be towards either stored procedure or user-defined function. We have two ways. A method without return type, a method with return type. A method without return type is called as a stored procedure. A method means a subprogram with return type is called as user-defined function. Any questions, guys?
No. No, sir.
Okay, so when it comes to real-time applications, for selecting data, mostly we'll be using views. Or for operating your partition tables, we'll be using views. But if you want to insert something, update something, delete something, inside view, you cannot write advanced SQL programming because it is limited. If you want to perform, if you're going to perform any operations, DML operations, data manipulation operations, DML, data manipulation operations, means insertion, updation, deletion. If you are going to perform any DML operations, then your approach should be towards stored procedure or user-defined function. Okay, so in 99% cases, we use stored procedure to perform DML operations. We do create our own stored procedure to perform DML operations. Okay, so let's see how to do this. For example, here we have part 1, part 2, and part 3. And we can take customer table also. Select, start from customer. Okay. Now, if you want to insert data into customer, you have to write a SQL query like insert into customer, right? And field names, customer is an identity column, CNAME, gender, country, membership type, and amount paid. Values to be supplied to those respective columns. CNAME, some DF can give anything. Gender, male, country, USA, membership type, silver, and amount paid, some $2,200. Right? Here, we are hard coding these values. But technically, when it comes to real-time applications, for example, not only this, if you take a registration page, registration table, from where the data will be coming. So whenever a new user wants to register his ID, he will go to registration page. There he will enter all the details. Whenever I click on save button, what happens? The data will go to the backend database. There the data has to be saved. So technically in the real time, this data will be coming from your front-end application. Here I have hard-coded these values, but it is not like this. Whatever came from your front end, only those values should be inserted into your backend database, right? We cannot hard code and we cannot insert manually like this, right? So these values are going to come from your front end application. Whenever I perform any transaction or I save something, update something, The data will come from your front end to back end, your database server. So these values are going to come from your front end. Right to me. So if you're expecting something to be supplied from the front end, your front end is going to be your calling environment. Who will call this SQL query? Whoever wants to insert your data, whoever wants to update the data, whoever wants to get some data. So they will call these queries, right? So that environment will become your calling environment, right? So whoever wants to save the data, they need to call MySQL. That will become calling environment. And from where these values are going to come, these values are going to be coming from your front-end application. Alright to me. So as I said, you can pass a direct SQL query like this. There you can prepare a SQL query like this and send it. But if I send something like this, SQL injection will come into the picture. SQL injection will come into the picture. If this gets hacked by someone, they might insert some malicious data here. Alright to me. That's why always we have to use a view or stored procedure, right? But view doesn't take any parameter. So in this case, these values should be supplied from the calling environment. So in order to get these values from the calling environment, so your subprogram should have these many parameters, right? So if I go with view doesn't take any parameters, then what should be my approach? My approach should be stored procedure. Now what should I do? I should not hard code these values. Rather, I should take these as parameters. Whoever calls my stored procedure should supply values to these parameters. Alright, I mean, now I'm going to create my stored procedure. How do I create it? Create procedure, like your view, create procedure, procedure name. Okay, you can give any name. Let's I'm giving it as stored procedure SP underscore save customer data. You can give any name. Save customer data. Now, if anyone calls my SP, whenever they want to save data into customer, they don't need to send a SQL query like this. Rather, they just need to call my stored procedure and they have to send these values from the calling environment. Your stored procedure is nothing but a subprogram. If you're expecting something to be supplied from the calling environment, so what has to be done? You should take those respective parameters. For C name, you have to take one parameter. To capture gender, you have to take another parameter. To capture country, you have to take another parameter. To capture membership type, you have to take another parameter. So how do I declare my parameters? You have to use, according to syntax, you have to use @ symbol. @ symbol, right? In C# we will declare something like add of int a comma int b comma int c. Right? If I say int a comma int b comma int c, so what happens? It expects 3 values to be supplied from the calling environment. But in our case, we are expecting these many values to be supplied from the calling environment. So you have to take, to accommodate these many values, to let user supply these many values, here you have to take those many parameters. So I'm taking the parameter name. So parameter name should start with @. Okay. So first one is going to be C name, @C name. And what is the type of this? Varchar, comma. Next parameter, gender, char of 1. Next parameter, country. This is going to be varchar of some 50. Next parameter, membership type. This is going to be varchar of 50. And next parameter, @amount paid. This is going to be money. As now, keep your SQL inside this. This is my subprogram name, and this is definition of my subprogram, and this is going to be body of my subprogram. Now, what happens if anyone calls my SP, my stored procedure, my subprogram? Your stored procedure is nothing but your subprogram. If anyone calls your stored procedure, they have to supply these values. Now, what has to be done? Here you don't have to hard code it. Whatever is coming from the calling environment, whoever calls this SP, they will need to supply this. And these values are going to come from your calling environment. And whatever is supplied from the calling environment, only these values should be inserted into your table. Now inside your SP, okay, write insert statement, insert into customer. And what has to be inserted? Now I'm not going to hard code anything. So whatever is supplied from this variable should be inserted here. Now CNAME is going to come from calling environment, and whatever is supplied into CNAME should be displayed, should be saved into CNAME, and whatever is supplied into gender should go to gender, and whatever is supplied into country should go to country field. Next, membership type. Next, amount paid. Now what happens? I did not hard code anything. If anyone wants to insert data into customer table, they don't need to send any SQL query directly from the calling environment. Rather, call my SP and supply these values. Call my SP, call my subprogram and supply these values. That's it. I've written an insert statement inside my subprogram. This will take care of values supplied from the calling environment. This will take care of inserting, saving data supplied from the calling environment. Now execute it. Now what happens? The stored procedure will be created physically in your database, and your SQL query will be stored within the stored procedure. And the SQL query will be compiled only once throughout the lifetime during your stored procedure creation. And whatever the compilation plan is generated during the stored procedure creation, that will be stored with your stored procedure. And when it comes to subsequent execution, this will be executed directly without any compilation, like your view. Now go to your table, database. Now we have seen tables under table category, views under views category. If you go to programmability, all your stored procedures functions will be available here. Under stored procedures, I can see, this is my stored procedure. SP save customer data. Now what happens? This has been stored physically in my database. And whatever the query is written inside this is also stored physically in my SP. Right? Now, if I want to save customer data, I don't need to send any insert statement from front end. I just need to call this SP and supply these values. I just need to call this SP and supply these values. If someone hacks your stored procedure, what happens? They can see the name of your stored procedure, but they cannot see what is there inside it. So your query is safe. So it is very difficult to hit your query. Any questions, guys, so far?
No, sir.
No.
Okay, so what is the difference between view and stored procedure? See, the view creation is also very similar. The thing is, your view doesn't contain any parameters. Before as, I cannot take any parameters. But here, it is very similar. If I remove this, it is very similar. It takes parameters. If you're expecting something to be supplied from the calling environment, that is not possible through your view. That can be possible through only your stored procedure. Okay, so that's why. So stored procedure is like your subprogram. It is very similar to your subprogram. A subprogram without return type is called stored procedure. A subprogram with return type is called user-defined function. So what is the difference between these two? A stored procedure doesn't return any value directly, but a function returns value directly. But both are subprograms only. Okay, now how do I call my SP from calling environment? Right? So let's see this. Select star from customer. Let's see how many records are there in your customer table. 12 records are there. Now, let's go to calling environment. Let us assume that this is our calling environment. This is our UI. Now, I want to insert customer data using the SP that we have created. So what is the SP name here? Your SP name is this, SP save customer data. From anywhere, not only from UI, from anywhere, if you want to insert any customer record into your database, you don't have to send any insert statement. Rather, call this SP. From wherever you want to insert it, just call this SP. How do I call it? Here you have to use a command called exec. exec. execute. Ex means execute. We are saying that call this SP. Okay, if I want to call this SP, what has to be done? This SP will take care of inserting customer data, right? So that's why it expects customer data to be supplied from the calling environment. Means these many fields to be supplied. So if I want to call this SP, what should I do? I should supply values to these parameters. First, CNAME, SP name. Next, gender, female, comma. You have to supply like this. Parameter 1, comma, parameter 2, comma, parameter 3, comma, parameter 4, comma, parameter 5. Next, country. India. Next, membership type. Gold. Next, amount. $3,000. Right? Now select this statement. See, what was the last record? We have it at 12th position. 12 AAA. Now, we are not writing any SQL query. We are calling this SP and passing the customer information. Now, this SP should take care of executing this. Let's execute this. Select this and execute this. One row affected. Let's go and see this. Select star from customer. See, it got inserted. Right? So, when it comes to real-time applications, in case of insertions, updation, deletions, we be using only stored procedure. Whenever you want to perform an insertion, deletion, updation, you have to write your own stored procedure and take those many parameters to be supplied from your calling environment. Any questions, guys?
No.
So this is something about your stored procedure. Next, how do I, for example, I have two stored procedures. SP1, SP2, SP3. SP1 will take care of performing operation 1. SP2 will take care of performing operation 2. SP3 will take care of performing operation 3. In this case, I am going to write another SP, main SP. Can I call one stored procedure from another stored procedure? Yes, you can. Can I call a view from stored procedure? Yes, you can. Are you with me? This SP1, SP2, SP3 can be called from another. Either one stored procedure can be called from another stored procedure. A view can also be called from stored procedure. For example, after this, I want to call view select star from. This is a stored procedure. Inside stored procedure, I'm writing another statement. Select star from view. What is the view name? Are you with me? Okay. So if you want to alter anything, just keep alter statement. What I'm doing, whatever is passed, it will take care of inserting data and returning this view. Are you with me? Now, if I insert something, what happens? SP name 1. What happened? Data got inserted and the view got executed. It has selected data from view. Select star from customer. See, my data got inserted as well as. So like this, you can call one stored procedure from another stored procedure. You can call a view from stored procedure, but a stored procedure cannot be called from view. Why? If stored procedure takes any parameter, that should be supplied from the calling environment, but where view doesn't take any parameters, right? So that's why a stored procedure cannot be called from a view, but a view can be called from stored procedure. Any questions, guys?
No, sir.
No.
Okay. So mostly when it comes to real-time applications, to perform insertion, deletion operations, we will be writing stored procedures. So not only input parameters, you can also take output parameters. If you want to return something back, some result, int, you can make it as an out parameter. Out means output, like your C#. Like your C#. Right? So from stored procedures, a stored procedure doesn't return any value directly. If you want to return something back to calling environment from your stored procedure, you should take it as a out parameter, like your C# out parameter. Ready me? Now, if I keep anything into result, if I keep anything into this, here you would use a keyword called set. Result is equal to some 100. Now what happens? So whatever is set into this will be accessible to the client environment. This will be accessible to the client environment. So that is the use of your out parameter. Any questions, guys?
No, sir.
No.
So SP takes both input and output parameters. Okay, it doesn't return any value directly, but if you want to return something to calling environment, it should be returned through a output parameter. But when it comes to function is not like your SP. Function returns value directly to the calling environment, like a method with return type, something like int add. This is something like void add, and your function is nothing but int add. So it returns value directly to the calling environment. Next, like your try catch. For example, see here we have written only 4 lines of code, but when it comes to real-time applications, we'll be writing 1,000 lines of code. Now, how do I handle my exceptions? How do I handle my errors? Like your C#. In C#, whenever you need to handle the exceptions, we used to implement try catch blocks. Here, how can we handle the exceptions? If something happens in my code, how do I trace it? How do I debug it? So here also you can do the same thing. Here also you can implement same try and catch blocks. What has to be done? Your entire code should be placed into try block. Begin try and end try. This is your try block. Okay, and this is normal required. Begin try and end try. Okay, it means this is a try block, and within this you can place n number of lines. So your action has to be placed inside try block. How do I define it here? You would use begin try, end try. So this is your try block, and between begin try and end try, you have to keep your action. You can write n number of lines of code. Next, begin catch, end catch, and there is no final block supported here. Okay, here you would write only try block and catch block. So what happens if any exception occurs here? Immediately it will go to catch block. Here you can write anything. If you want to print something, use print statement. Error. Already mean. So if you want to implement exception handling, you would implement like this. It is very similar to your C# try catch. Place your action inside your try. If any error occurs in your try block, immediately it will go to catch block. How do I define catch block? There we used to write braces, but it is not like that. So it is another programming language, right? So every programming language will have their own standards. Here you would write something like this: begin try, end try, begin catch, end catch. Any questions, guys?
No, sir.
Okay. So how do we handle exceptions in SQL? You have to implement try block and catch block. Your entire action has to be placed inside try block, like your C#. If any error occurs in try block, immediately control will go to corresponding catch block. Here, you have to trace that error and throw that error message to the end user. So this is something about your stored procedure. Next, user-defined function. So user-defined function is nothing but a subprogram with return type. You can directly return value to calling environment. So how do I create it? So it is pretty simple. And you can also create it from here. This is stored process. All your stored process will be stored under this. Next, when it comes to functions, we have some system-defined functions. Okay, so every system will provide some built-in functions. Here you can see aggregate functions. Here you can see these are different types of system-defined functions. Okay, and date and time functions, mathematical functions, metadata functions, other functions, hierarchy. So these are all built-in functions. If you don't want to write your own program, for example, you wanted to find sum of 3 numbers. Here we have some aggregated functions here. Average, count, grouping, max, min, return. So if you want to make use of these built-in functions to perform your operations, you can use them. Otherwise, you can write your own program. So these are the built-in functions which are being provided by your SQL system. That's why we are calling it as system functions, like your base class libraries. In C# we have system.math. What is a math? Math is a system defined library which comes with set of built-in functionalities like sine, cos, tan, average, sum. So here also we have some built-in function support provided. Those are available under system functions. So if you want to make use of them, you can. Okay. Next, when it comes to functions, user-defined functions, we have two types of functions, scalar and table value. I mean, scalar means if your function is returning a single value, that is called scalar. Your function can also return a table, collection of rows, arithmetic, that is called table value. But both are same. If your function is returning a single value, we call it as scalar function. If it is returning collection of rows, we call it as table value. So if you want to create it, just click on new scalar value function. The syntax and everything will be appeared here. What is the syntax? Same, create pros, like create function, function name. I'm giving it as like find sum and parameters. Okay, let's say a int comma b int. I want to take 2 parameters, something like add of. You can also give it as add function, add, subtract, multiplication. Like you create stored procedure name, like create pros name, create function name, and parameters. This is going to take care of adding 2 numbers. Thus, I'm taking 2 parameters, something like int a comma int b in C#. Here it is reverse. Variable name should start with @ a type is int, b type is int. You can take a number of parameters. And returns, what type of data is going to be returned? It is going to return int. Something like this. In C# we write something like this, right? Int add of int a comma int b. It is similar, right? So this is your function name, add. In place of int a comma int b, these are the parameters to be supplied from the calling environment. We're taking it as a int, b int. And what is the type of return? It is going to be int. So returns int. So this function is going to return int. And this is body of your subprogram, body of your function. Here you can write in anything. And just writing it as return a plus b. Return me. Just execute it. So this function got created. Now you can reuse this function anywhere. Whenever you need to find sum of 2 numbers, you can make use of it. And this will be stored physically in your database. You just refresh it. See, here I can see my function. Right? Now, how do I call it? The beauty of this function is the main difference between stored procedure and function is, first, let's see, how do I call it? You can call it directly into select dbo dot your function name, and it takes 2 values, 10 comma 20. Execute it. See, 30. Right? So the main difference between stored procedure and function is stored procedure takes both input and output parameters, whereas your function takes only input parameters. And stored procedure supports error handling. You can use try and catch a block to handle exceptions, but your function doesn't support exception handling. And third difference, it returns value directly to the calling environment, but whereas your stored procedure doesn't return any value directly. If you want to return something, you have to take output parameters. But you're not only one output parameter based on your requirement, you can take more than one output parameter also. That is the main difference between your function and stored procedure. And your function can be directly called into select statement, like your table. but your stored procedure cannot be called into select. Whenever you want to call a stored procedure, you would use a command called exe. It has to be executed separately. That is the difference between function and stored procedure. Any questions, guys?
No.
No, sir.
Okay. So now we have completed the concept of views with the different options like schema binding with check option, partition tables, partition views, stored procedures, and functions. We have one more section left. Tomorrow in next session, we will be covering the concept of triggers, transactions, their intents, and temporary tables. That will be covered tomorrow session. Okay. So we are going to complete it tomorrow. Okay. And from day after tomorrow onwards, we will start implementing GUI-based applications like Windows and web. From there, we will be calling all this. We call SQLs, we call stored procedures, we call views, and we call user-defined functions. And here, a function can be directly called from your stored procedure, but a stored procedure cannot be called from function because your function takes only input parameter. It doesn't take output parameter, but your SP takes both input and output. That's why a stored procedure cannot be called from a function. It cannot be called from a view. But view and function can be called from a stored procedure. That's why mostly we'll be using stored procedures. When it comes to stored procedure, anything can be called from your stored procedure. There are no restrictions. And exceptions can be handled properly. You can make use of advanced programming options. That's why when it comes to real-time applications, if you want to extract a single record, it should go through SP. Okay. This is one of the ideal thing to be used in real-time application. This because it will reuse the execution plan. When you talk about SP, this is not the pre-compiled code. So whatever is written inside your SP, this will be compiled only once, and the execution plan will be reused towards subsequent executions. So this is kind of pre-compiled code. So it will be executed directly without any compilation. So it will speed up your process. Second thing is, whatever is written inside this, it is safe. It provides the security. Whenever you want to execute this, you just need to call your SP. See, here we are calling our SP. But whatever is written, if this gets hacked, they cannot see what is there inside your SP. They can just see your SP name, but they cannot see what is there inside your SP. So whatever is written inside your SP, that is safe. It is very difficult to hit that part. Okay, so it provides a lot of security, it provides reusability, and it will be executing very faster because it will reuse the execution plan. It is a pre-compiled code. Okay, so now I want you to practice these things. So create an employee table. I'll give some assignment. Create an employee table with the following fields. Employee ID, it should be identity and primary key. Key primary key also. EMP name, it should be not null. Gender, it should have check constraint. Check in, because the possible values are going to be male, female, and other. Salary, next department ID. And before this, create a department table. Create department DPT ID. This is identity column as well as it will have primary key on it. DPT name, next DPT location. This is the master table, because whenever you want to start some business, right, first you have to configure the departments of your organization. Then only you can start recruiting the people into respective departments. So here, when it comes to department ID, you should create a foreign key relationship between department table and department ID. Here you should keep foreign key. Okay. So create this table, then create a store procedure. Create a procedure to save employee data. Create a procedure to delete employee data. Create a procedure to update employee data. Next, create a view to select employee data. Guys, are you following me?
Yes.
Yes.
sir.
So
Yeah.
here I created a store procedure to save the data, right? If I want to delete it, so how do I delete the data? So whenever you want to delete something, okay, so you should supply a key field. For example, what should be my plain SQL statement? Delete from employee. When it comes to, we have two options: delete, truncate. If you want to delete something from your table, you can use either delete or truncate. So what is the difference between these two? So what delete will do? So as I said, whenever any new database is created, two files will be created: dot MDF master data files and dot log. Your actual data will be stored on the master data file, and transactions that you are performing in your database, like inserting something, updating something, those are called transactions. The transaction history will be saved into log file. If something is deleted, first that will be stored into log file. Ready? Something is saved, that will be recorded into log file. So those transaction details will be maintained on the log file. Okay. So whenever anything to be deleted from your table, you can use either delete or truncate. This is very important question. What is the difference between these two? If I delete something using delete, this will get recorded into log file. If I delete something using delete keyword, this will get recorded into log file. Let's say I deleted something, then I realized that I deleted wrong record. So if I use delete, I will have a chance to roll back my record because it will be stored into log file. If I delete something truncate, straight away it will be deleted permanently. Nothing will be maintained in your log file. Are you with me? If I delete anything using delete, I will have a chance to roll back it. If I delete something using truncate, nothing will be recorded into log file. So this is kind of permanent delete. It will be deleted immediately. You will not have a chance to roll back your data. Okay. Okay. So what is my statement? Delete from customer. Where which record has to be deleted? If I say, if I use name, where C, if I say where C name is equal to A, what happens? Will it delete only one record or more than one record? Whoever is having name as A, all those records will be deleted. Are you to me? So that's why whenever you want to delete something, we should always suggest use a unique key field. Unique key field. If you want to delete something, update something, use the unique identity of that particular customer, particular entity. What is the unique identifier of the customer? Customer ID. If I use name, if I want to delete Prakash record, if I say where C name is equal to Prakash, there can be more than one Prakash, right? And all Prakashes will be deleted. That's why, especially if you are going to perform any updation or deletion, do not use non-key fields. Make use of key field in the where condition so that only that particular record will get affected. If I use non-key fields, this can be repeated for other customer, other employee also. So there may be a chance of losing more than one record. So what should I do? Instead of C name, I should use customer ID. If I say customer ID is equal to 1, only one customer will be having this ID. So only this record will get affected. Okay. Now it will be deleted. If I want to do it through stored procedure, what should I do? This value should be supplied from the calling environment. If anyone wants to delete it, they should supply this customer ID. So I would be needing only one parameter. So create a procedure, create pros sp underscore delete customer. Now how many parameters I would be needing here? Only one parameters. Okay, only this value has to be supplied. So I'm taking it as parameter customer ID int as my statement. Delete from customer, where customer ID is equal to this thing. Customer ID supplied from calling environment. So whatever is supplied from the calling environment, only that particular record will get impacted. Execute your SP. Yeah, it got executed. Right now I can see two SPs. Delete customer. Now, if you want to delete anything, I just need to call this like this. How do I call a stored procedure? exec sp delete customer. If you want to call this, what has to be done? It expects one parameter to be supplied from the calling environment, that is customer ID. You should tell the system which customer has to be deleted. For example, I want to delete this customer 10. Customer ID is equal to 10. Now I need to supply that value. Execute it. One row affected. Let's go and check. Earlier 10 was there. Now let's check. See, 10 is not there. It got deleted. In the same way, update. I would like to update the membership type through. I'd like to update membership type through a stored procedure. So how do I write it? I have to create another stored procedure. Create pros. First, write your SQL statement. Then you will get to know how many parameters are to be taken. How do I update it? Update customer set membership type is equal to, for example, ABC, where, for example, I would like to update the membership type of particular employee. When you want to update any data of that particular employee, so what has to be done? That particular customer ID unique field value has to be supplied, where customer ID is equal to 2. Now what happens? This particular customer record will get updated with ABC. In this case, how many values are outputted here? 2 values. So if you want to update the membership type of any customer, you would be needing 2 values to be supplied from the calling environment. What is, which customer record has to be supplied? Customer ID. Another one is, it has to be updated with which membership type? Gold, silver, or bronze? Okay, let's create a procedure. Create procedure sp underscore update customer. Now I'd be needing 2 parameters. One is customer ID integer, other one is membership type var of 50. As now write it, where customer ID is equal to no hardcode, whatever is supplied from calling environment. Membership type is equal to membership type supplied from calling environment. Right? Now execute it. My SP has created. Now if I want to call this, if I want to update any customer, now what I will do, I'll just call this SP. But what should I supply? It expects which customer ID and what has to be updated. It expects 2 values to be supplied from the calling environment. Right? Now I'd like to update. Select start from customer. Let's see how many records are there. For example, I would like to update this 5th one with gold. Okay, this 5th record has to be updated with gold membership. Now I should supply the customer ID as field, and what has to be updated? Membership has to be updated as gold. You have to give exec. Got updated. Let's check. Earlier it was platinum. So now it got updated with gold. Not only membership type, I would like to update amount paid also, because this membership fee will be increased, right? So if you want to supply one more value, take one more parameter, amount paid, money. Yeah, not only membership type, I'd like to update another field also. You can update n number of fields. Amount paid is equal to what has to be updated? Supplied from the calling environment. Value supplied from the right. So here, this is existing stored procedure. If you are modifying any existing view or existing stored procedure, what has to be done? You have to use command called alter. Okay. Now execute this. Now what has to be done? For example, select star from customer. For example, this guy, this particular customer number 4 is having platinum. Now I wanted to update his membership type as well as amount paid. Now what should I do? Not only this, which record has to be updated? 4th. Membership type is gold and amount to be updated as 1200. Now go back. Earlier it was 800 and platinum. Now gold and 1200. Okay. Now we have seen almost all operations, right? We have seen how to insert data through ASP, how to update data, how to delete data. Okay. So now I want you to write this thing. Create a department table with these fields. Create employee table using all constraints. Now create a procedure to save employee data. You have to pass all employee fields from front end, from calling environment. So it should take those many parameters. Delete employee data. If I want to delete the employee data, only the particular employee has to be deleted. So what has to be taken to delete it? The unique field, employee ID. Update data. Okay, you need to update multiple fields. Next, select data. Okay, so you have to complete this assignment and send it to me today. Okay.
Okay, sir.
Any questions?
Okay, thank you.
Okay,
No, sir.
we'll meet tomorrow.